Hello, welcome. We finished the last video filling out a contingency table for the last problem, looking at conditional probability. So I want to do just kind of a quick summary of the multiplicative rule, probability that A and B happen. So from before, we have the probability that if A happens, assuming B happens, is the probability of A and B divided by the probability of B. So if you can go back to your algebra class, we could multiply both sides of this equation by the probability that B happens. And get this formula here. The probability that A and B happens is the probability of A if B times the probability of B. I know this notation could be cumbersome, especially since this might be the first time you've used it. But this probability of B is just like X. The probability of A if B would be just, like a Y. Doing like an algebra equation. And notice we could do the probability of B times the probability of A if B, or we can write the probability of A and B as the probability of A times the probability of B if A. And as before, I would write these both down on a piece of paper. Just have them in front of you when you're working on homework problems and problems through the textbook. All right, let's try to use it for one question. 60% of elementary stat students rank their college experience as excellent. And this was the first choice for 49% of those who ranked their experience as excellent. What percentage of stat students had this college as a first choice and ranked their experience as excellent? All right, I'm going to pause for 10 seconds here. If you need more time than that, pause the video and see if you can get this question. All right, let's look at this. 35%. So we're looking for the probability that a person says their college is their first choice, was their first choice, and their experience was excellent. So this 59% was the first choice for those who rank their experience as excellent. So we want to get used to kind of translating the sentence into if excellent. We're assuming they selected excellent as their college experience. So the probability of first choice and excellent is the probability of excellent times the probability of first choice if excellent. So keep in mind, whatever this event is, that has to go along with the if event in the second probability. So we just need to multiply the 60% times 59 to get 34.4%, around 35%. Okay, summary on probability rules. As I said before, I'd encourage you to write these down. Have them nearby on a piece of paper when you're going through homework. There's the additive rule, A or B, inclusive or. The and rule, the multiplicative rule, the complement rule, not A, and then we have the conditional probability rule. And I do expect you to be able to use these and apply these in the next couple weeks going through homework assignments and whatnot, and then for the first exam. Okay, so I want to talk about our last two topics are types of events, disjoint. So what does it mean for two events to be disjoint or equivalently defined mutually exclusive? That means if only one of the two events can happen at the same time. So two events are disjoint that are not disjoint. So let's say two events that are disjoint. I think the most basic one is if you flip a coin, the only two events that could happen are getting heads or getting tails. Those two events are disjoint. You cannot get, if you get heads, you can't get tails. If you get tails, you can't get heads. Two events that are not disjoint, you can think about flipping or pulling a card from a standard 52 card deck, getting a heart, and getting a queen. Would be two different events, but they can happen at the same time. So I would suggest, see if you could write down two events that can't happen at the same time. The Warriors winning the national championship, NBA championship, and the Cavaliers winning the national championship cannot both happen. Alright, so if A and B are disjoint, disjoint meaning that they are separate, they cannot happen at the same time, then which of these two do you think would be true? Well, going back to the A or B, the probability of A or B in general is the probability of A plus the probability of B minus the probability of A and B. Don't forget that double count we talked about a couple of videos ago. But if A and B are disjoint, this probability that they both occur has to be 0. So this formula in red is always, always, always true. But if you know events A and B are disjoint, you could simplify this OR formula. I'd rather you kind of have this one, keep this formula close to when you're doing the homework and whatnot, because it's never wrong to subtract 0, because that's all you're doing with these disjoint sets. And here's the general A or B visually. A happens, B happens, or they both could happen. And this minus A and B is to not double count. But if A and B are disjoint, this picture is going to change to this. A and B do not touch each other. They don't intersect at all if A and B are disjoint. So that's why we could just omit that minus A and B. Okay, in the next video, we're going to talk about what it means for two events to be independent.